Recently I've been watching a lot of coding videos, and he's been doing a lot of stuff with Raylib, which inspired me to look into Raylib. And it's quite nice to use. So today we're going to do a little bit of a project with the Raylib. We're going to be looking at visualizing random walks, which I think could be interesting. So here we have a new folder, new empty folder, and let's start a tmux session, and we will make a file called main, and to run it we'll make run.sh, and I think we're going to do something like this, and we're going to say output main from main.c, and we'll need a bunch of flags, but I don't fully remember what they are. Let's say include. We're gonna need to at least include Raylib itself, which is something like this. Let's just see what's in here. So there is opt Raylib source, so that looks right. We'll include that. And this script is then gonna compile it and then run it. So let's see if we can get this basic thing working. We're doing it in C because I cannot be bothered to figure out how it works in other languages right now. So I have some kind of annoying thing installed. Let's try to remove that before we go much further. It's this one, and how is it you uninstall? I think it's just X. So let's get rid of this guy and quit everything, restart it. Now it shouldn't be complaining. Nice. All right, so here we are. Let's print something. Hello. And return 0. Let's see if we can get this to work. It does not work. Let me check something out here in my config. So we have here, when I press leader Q, it's the run command. And let's add another one. If it's a C file, then we're gonna return command sh run this .sh, and let's go back. Now we need to restart, and now we're up and running. Okay. So apparently that was enough, which I'm a little bit surprised by. I would have assumed. Okay, so we're just including, but now let's try to start a window. So to do that, I think it will be helpful if we have the Raylib header opened here, because then we can look at the different functions, which are quite well named. For example, we have here init window, which is the first thing you need to call before you do anything else. And let's put here, I don't know, size t, width. Let's call it window width, window height. The reason I'm putting them out here is because we might want to support resizing, and then it's nice to have these variables somewhere where they can be accessed generally. So let's do something like this. And then you say, no, sorry, while not window should close. Then yeah, begin drawing. We'll make a white background. Actually, we can make our own color, which let's make it like this. And then we just put color here. And sure, we can, let's draw color in red. And then what you do is you say begin drawing and end drawing. And then I think here we have to say close window to kind of, which also does a lot of stuff with deallocating resources and so on. So now this shouldn't work. Right, and it's failing in the linker. So we need to go back here and then we have to, yeah, do something like this. And I do think, because I built it myself, I think the library is actually at the same place where the source code is. So let's just check that. Maybe because I didn't build it correctly. Okay, it's super hard to see. Yeah, so we have it here. This is the library file. So let's link to Raylib and let's leave it at that for now. Right, so that's a little bit closer. So something I'm seeing here is these like mathematical functions. So let's also link to the math library. And that did help a little bit. And then there is these DL open, DL close, which is like dynamic linking. So I think it's like that, we have to say. That removed a little bit more. Now there's some pthread stuff. So let's link to that guy. And that was apparently kind of enough. I don't know why it's so huge. Ah, I think I know actually. Let's close that because we never set these guys to anything. So let's do that. And let's set it to 800, 600. And now we have a nice small window. And let's put this guy actually kind of in the middle. Like that. Okay. Right. I think that's good enough. So what I want to do is to try to visualize a random walk. And to do that, we're gonna draw a bunch of circles. So let's try to just draw a circle now. Without further ado. So center X should be, let's copy this stuff. And the color can be, let's make it white, kind of like off-white. Okay, so we can draw circles, which is good. So now let's try to make a random walk. So a random walk kind of looks like this in 2 dimensions, which is what we'll start with. It's usually defined on a grid, and at each, so it goes on in several rounds, and in each round you take a step either up to the left, down, or to the right with some probability. So let's try to do that. So we're gonna have a bunch of points. So let's define a type for that, just to think about it a little bit clearer. And it's gonna have an X location and a Y location. And that's it. And these are integers, so that's why I make them size t. And a random walk will then just return a bunch of points. So let's say a random walk, and it will take a number of steps. And it should also like, well, that's gonna be the number of points, so you already know how many points you're getting. So let's say points, we're gonna allocate some stuff like that, and at the end we'll return points. Okay, so we wanna make an initial point, which is just gonna be starting at 0, 0. And later on we'll decide on, in this function the step size will always be 1, and then later on when we draw it we'll decide how to draw it, like if a step, how many pixels is one step. All right, so let's see. Actually, it should probably start at 1. So we're gonna need a random number. And I wonder if this thing that GitHub Copilot gave me was correct. So apparently in Raylib there's this get random value, which presumably returns something between min and max. And is it inclusive? We don't know. So let's try to say yeah, exactly, and then we'll just return. Let's see what we get. And it's complaining up here. Maybe we do have to cast it. Okay, so we get a bunch of values here that are between 1 and 3 inclusive. So that's good. And we also need stdlib because we are calling malloc. All right, let's get rid of these two things. So this is actually a random walk. We get a random value, and based on that, we'll decide if we go right, go left, go up probably, depending on how we draw it, and go down, and then we assign that point, and I hope that here we're copying it. So actually this is correct. Okay, so now we need to draw it. So let's first get a random walk of 1,000 points. And then we will just try to draw that. Let's actually go up here and say number of steps is 1,000. Call this one number of steps as well. And then for each of these steps, we are going to get the point, and we will draw a circle at the middle, offset by these coordinates. So 0, 0 will be at the middle of the screen, and that is that. Let's try to run this. Okay, so you can see it's quite small, and we cannot zoom or anything. And that is because the size of the step is 1. So let's try to change that. Let's say we will put it here because it has to do with how things are visualized. Let's make it 5 for now. can see now it looks a bit more interesting. Actually, let's have a look here in Raylib, and I think there is like draw line. There is indeed draw line. Let's copy that and put it here. Because now we can say 0.1, 0.2, and then let's draw a line between those. So what's happening here? Let's make a little bit of a let's make some new lines so it's a bit easier to see. So again, we are drawing from point 1 to point 2, and it's in red, and I suppose we can also draw that's not what I wanted. So let's say P with P1 and P with P2. So we also draw some circles. So let's have a look at that visualization. Still, it's quite small. Let's try to do it without that. Okay, so this looks cool. This looks kind of like this plot. So 1,000, maybe 1,000 is not a very interesting number. Let's try to do 10,000. Okay. We can also try to do several runs. And let's do something like this. So let's say a number of runs will be like, let's do 5 runs. So can I do like this? Those are decent colors. And then we're gonna say, now my points is actually a pointer to a pointer, and we're gonna malloc size of like that, and then for each of these runs we're gonna be making 10,000 points. And then in here we're gonna say K, let's call it K, why not? Number of runs. Actually, maybe this one we'll call pointer to points. And then here we can say points is pointer to points K. And we will draw them like this, but we will actually draw colors of K. And here we go. Let's remove this and this. And it did not like that. And why is that? Excess elements, it's saying. Which doesn't make sense to me. variable sized object that may not be initialized. That makes more sense. So we have to make this thing a macro. And then let's actually rename it to big capital letters, as is the style. Okay. Now this is cool. So now we have multiple runs, all starting from the middle. And you can kind of see the different shapes you can get, different ways to explore the space. Let's try with like a larger step size. Okay, that's a bit too much. How about 10? Still too much. 5 was actually pretty good. How about 3? So you get much more interesting yeah, that's pretty cool. Pretty sure 1 is still, you get these like more big picture views when you do this, but still. So one thing that's a little bit annoying is that sometimes it goes outside, and I guess we can fix that if we say mod this by the width, and then same, but these guys were the height instead. Ah, okay, so now there's a problem that if you start here and then you go over here, you draw this like line. I mean, it looks kind of cool still, but also kind of glitchy. So maybe we'll just keep this as kind of like an alternate way of doing it. And we will do this. All right. We cannot resize. I think that's gonna do it for this video. This is just a quick start. I also want to see what happens when you're not moving on a grid and what happens in 3D. So I will see you in the next one.